Yes, it's time. Well, hello. This is the June the 30th session of excuse me, Zoom for ham-side tangerine discussion. My name is Dave, KV0S, and this week I've been doing a couple of things. I worked on, Dave Witten had a new set of code, and I compiled it. I've been running his code on the simple magnetometer for about 4 weeks now, and it hasn't crashed on me yet. And he's made several changes at the request of Holman. So now the software chunks the data into 1-day files. So, and it seems to be doing that fine. And so it's just cranking along, doing great things. Then, other than that, I've been doing some updating on my computers and changing some software. Right now, I've got a little bit of a different system for Zoom, so I'm not sure quite. It doesn't give me quite the same look as I had before. So now we'll go down the list. Next on the list is Nathaniel. Go ahead, Nathaniel.
Thank you very much. Thank you, Dave. Yeah, so let's see. I'm having a little trouble with my video camera, so we'll see how that goes. It's been a pretty busy week here. We just finished renovating my new office and ham shack, so that's where I am right here, and that's all coming along quite nicely. Let's see. I worked with Veronica today on analyzing some ham radio, RBN, and whisper data, which Bill has kindly prepared for us, so we've been working with that. And I've been working with Dev. He's going to be setting up a USRP at the University of Scranton. Hopefully this week. He has it in his hands and he's been playing with that. He can tell you more about that. Dev, you might be able to tell us how you found out what you found out about the GPS antenna. And we did have a short, small field day here. We had a Dev and a couple university professor come over to my house, and we wore masks and all that jazz. And we operated and got to use the new IC 7300 and play with the USRP. And that's pretty much what we did. So W2NF, back to net.
Very good. Next on the list, I have Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and hello, everyone. Well, I had kind of an aborted attempted field day this weekend, but didn't work out very well. I live in an apartment complex, and I had set up my antenna in the parking lot, and the apartment people took an exception to that and threatened to fine me $500 if I didn't take it down immediately. So I decided to take it down immediately. Anyway, I've been working a little bit on some scripts. This week I'm going to do a couple for the Odroid N2. I think I'm going to do Lin HPSDR and also WSJTX and possibly GNU Radio. I think I've done 5 for the Raspberry Pi so far. They all seem to be still working and working reasonably well. So back to you, Dave.
I have a question for you because I ran one of your scripts, the one for Pi HPSDR, and they're quite involved and they do work, at least that one did. Do you run each of these on a separate Raspberry Pi, or do you try to run all of them at once on one?
You can run them all at once, actually. They're all set up so that they compile in different folders or different directories. So there is no interference between them. The way I normally do it is to put I make a source directory, and then I run all of my scripts from that one directory. So if you in fact put all of the scripts you have in that same source directory and started compiling them one by one, you would have no problem. They would all compile independently.
What is if you put, well, you've got 4 or 5 now, but what size SD card do you need to?
I use a 32 gig.
Okay.
And one of them does take quite a bit of memory, and I can't remember now which one it is. GNU Radio takes quite a bit. And also, if you compile more than one, you're going to add additional code to your SD card, so that's going to be a problem as well. I think the most I've ever seen on the SD card is in the neighborhood of maybe 10 or 11 gig out of 32, so that's not so bad.
Dan, is
Tom,
this
did you have a comment?
Dan, is this natively compiling on ARM?
Yes. Yeah, I'm not cross-compiling. I'm natively compiling.
How long does the GNU Radio build take?
On the Raspberry Pi 4, it takes about 3 hours and 40 minutes. On the 3, it takes around 6.5 hours.
Very good. Well, good job. I have been trying those out, and a few at a time. I was listening to the SDR Academy this weekend, and I was working on compiling one of the scripts while I was doing that. So anyway, I'll go down the list, and next on the list we have Michael, AA8K. Go ahead, Michael.
Well, greetings, everyone. I enjoyed the Cedar workshop and the SDR Academy. Attended as much as I could. Back to you, Dave.
Fine business. So next on the list we have Bill. Go ahead, Bill.
Thanks, Dave. Well, as you may recall from last week, I've got the Tangerine SGR local host working with the simulator I wrote that simulates the Tangerine data engine. And I took a PI, that is Pi HBSDR, and modified it so it would spit out IQ data into a UDP format. And my simulator picks that up and rebroadcasts it in UDP in the same format that we expect for the Tangerine SDR data engine to produce. So I'm able to pick that up. I'm able to simultaneously run snapshotter mode and output an FFT of the data I get, as well as save the data to digital RF. And so I did a little bit of characterization of the Raspberry Pi just to see what I could get. And it seems that the Raspberry Pi clock is inaccurate enough, which we knew. It wanders around plus or minus about 0.75 hertz just on its own, even when you have a fairly stable 10 megahertz or 15 megahertz signal. So I can't really do Doppler tracking using just the Raspberry Pi. So I spent about a day and a half trying to see, looking at all the stuff online about this, see if I could get the Flex radio to output an IQ stream, which I could pick up and then deal with that in the Tangerine SGR mode. And a lot of the documentation that's online doesn't work the way they said it does. To be fair, a lot of it is several years old, and there have been a number of major revisions to the Smart SDR software and the firmware that runs on the Flex in the past several years, including particularly going from version 2 to version 3 of Smart SDR. So I haven't got that worked out. If I can figure out how to get the flex radio to output an IQ signal that I can actually get it to come out to a predictable port, then there's a VITA 49 standard which you use to bust up that packet, and then I should be able to output it in Tangerine format. I haven't gotten there yet. I would like to do that so that I can actually verify that all my post-processing and FFT and everything is working right using the GPSDO disciplined oscillator, which I have hooked up to the flex to run its clock. So today I spent most of the day, which feels like, it didn't feel like it was very productive, but adjusting my simulator. Right now, every time you want to restart it, you have to manually stop it and kill the process. So I thought maybe I could fix this thing so that there would be a master process which has a sub process that it could kill. And so all of the very complicated and elaborate automatic port selections that I'm doing in order to satisfy what Scotty asked for, it's a whole lot more complicated when you have multiple processes involved. And so I got it to where it's about 75% working, but then it doesn't select the channels. And I don't know whether it was a good use of time or not, but anyway, I have quite a lengthy list of things to fix and do, including some data stuff that I've got to do for Nathaniel, who needs to have some data going back further, back to, well, as far back as we can get the data. So I've got to set aside a day or two to work on that for him. But anyway, it's coming along. We've got our graduate student working on helping to figure out the optimal ways of uploading the data. I have a way that works, and she's going to evaluate that and see if there's anything additional or different that we should do. We got to figure out how to manage the user IDs and passwords for the accounts on the central host. Right now, what we're thinking is perhaps we will use the Case Western Reserve node naming node naming convention that they have, that they've been quite satisfied with, and then on top of that, use for a password, use the token. We already have a way of dealing with that with Django, which we can run on our central server. I did a little bit of analysis on the amount of expected data, and I sent Nathaniel something on that because our graduate student team would like to know the expected data volumes. It's hard to know what to expect, but we've got to start somewhere as far as an estimate. So we have a few estimates, and so I sent an email to Nathaniel about that, asking for his input. You know, how much data does it take, at least for phase one, to make for an upload that's going to make for good science? So we'll get the scientists' input on that and see where it goes. Okay, so back to you, Dave.
Bill, I would like to send you 1 day of magnetometer data so that you have a file that you can experiment with.
Sure, absolutely. Please do.
Next on the list, we have Tom Yarnish. He's usually just listening. Do you want to, any comments?
Here. Can you hear me?
Yes, I can hear you.
Okay. Yeah, Tom, KJ6MKI. Last name is Yarish. There's no N in it. Okay.
Oh, sorry.
My activities this week have basically been putting up a gap antenna. Rob, AI6VN, who I think you've all met, is working on with a lot of whisper stuff. Gave me a gap antenna, vertical, and I'm resurrecting that from the dead and getting it ready to put up. We'll see how it works on HF. Thinking about just dedicating a multiband whisper transmitter to it, but I want to see how it performs first. Other than that, I'm putting together a couple of loop-fed array Yagis for 6 meters, and want to do some polarization experiments with those as soon as I can get them in the air. Otherwise, we're just bumping along here. I'm a little edgy this evening. I just put a plum pudding into the oven with fresh local plums. I've got to keep an eye on that. Otherwise, you know, I've been following the Hamsci group for a couple of years, and it was never clear to me what you guys are doing with all the whisper data that you compile, and what you're doing with the magnetometer data, how it's being integrated into other projects, or how you extract or assign value to it. And that's the question I have for the group.
Well, we're a work in progress, and so part of it is getting all the pieces together, but there are many different ideas in our group of how to utilize that data. I'll let others comment as well.
I'll be happy to say a few words on that. I can do it either now or after the or in the general discussion.
I'd like to get through the list first, and then let the general discussion.
Yeah.
Thank you.
So next on the list, we have Dev. Go ahead, Dev.
Hello, good evening, everyone. So it has been a busy
Volume?
week. Hello? Hello?
You're very weak. Signal.
Hello?
There should be a volume control on your sound where you can turn up the audio of your microphone.
It's maximum. Hello? Hello?
I can hear you, but you're very weak.
Yeah, on your laptop or PC, go to the sound control panel and pull up your microphone, and increase the audio of the volume of your microphone.
I did, and it is maximum. I have already set it to maximum. Okay. Let me see.
Yeah, you can do it from Zoom too.
I don't think we can hear it very well. Dev, why don't you work on that a little bit, and we'll come back to you.
Hello?
Okay?
Hello?
You're still very weak.
Okay, yeah, thank you.
Next is David, N1HAC. Go ahead, David.
Hello, everyone. Primary thing on our topic probably was trying to work out VLF antenna and calibrating it, because I'm working on a project rocket where we want to monitor NAA from here and have a good measure of signal strength, so we can compare it to what the payload picks up. Currently, we're hoping to fly that in January or February, but who knows when NASA's going to open up again, and we can get moving on that project. It's called the Viper mission. But I also did do a lot of field day this year. It was certainly different, and it was a good emergency exercise. And I did a lot more operating. Well, I operated from home, which I've never done before for field day. Our club did a number of different things. We did have some on-site. We had some remote operation, and then encouraged our members to work from home. And the most contacts I've done in the past, being that I'm more into the setup and teardown, has been when we had a good 6 meter opening, because I like to set up the VHF station and run that. But 6 meters was nothing this year. So I ended up operating on 40 and 20 meters. And as I would say, did reverse propagation. In other words, I was doing 20 meters at night and 40 meters during the day and having good results. And in fact, I heard but was not able to contact Angel, WP3R. He had a great signal up here. and a great pileup, of course. So I couldn't get a word in edgewise. And it's not that I couldn't get to Puerto Rico, because I did make a contact with someone else down there. But propagation is doing weird things these days. And I look forward to having a network of stations to have a heads up on what's going on. Thanks. Back to Net.
Okay. Dev, you want to try?
Let's try. Is it better?
Much better. Much better. Go ahead.
Thank you so much. So I'm finally Dave here. We had a good weekend. We went to Nathaniel's new office and participated in the context. And I also learned to fit the N200 USRP device. I fitted GPS Duo, GPS oscillator, and also daughter board into the N200 USRP device. So like I had never done any kind of experimental work since a long time, since my, I think, undergraduate experiments. My most graduate research was in data analysis. So it gave me a new experience after a very good while. I think we're getting started to have a HF receiver installed at University of Scranton, and once that gets started, I think we'll have data to receive, and we'll start analyzing that to see if there would be any meaningful science questions to understand meaningful geophysical processes in the upper atmosphere. Thank you.
Very good. Next on the list we have is Veronica. Go ahead, Veronica.
Hi, everyone. So last week I went to the CDAR workshop and I found that very interesting. I definitely learned a lot. And then also I've been working with Dr. Purcell to create some graphs to help analyze the correlation between days of high KP indexes and ham radio spots. Yeah, thank you.
So that's one of the things, Tom Yarsh, I think he just walked off. So Veronica's actually working with that, well, not the WISP, yeah, with the WISPR data and the RBN data. Did you hear that, Tom?
No, I'm sorry. I had to leave the room. My cake was beginning to cook.
Oh, okay.
I
was just saying, Veronica, she was just telling us about what she was doing, and she's one of the people working with the WISPR data.
Okay, I'm really interested to know. I've been putting so much power into the atmosphere for all these years and these different WISPR beacons. I run it, running 4 or 5 now, and I'm just beginning to wonder who's going to do anything with all this.
Yeah. Oh, well, yeah. So Veronica is one of the people doing things with it.
Okay, great.
And I am too.
Okay.
Back to Net, Dave.
You're muted, Dave.
Tom McDermott, it's your turn.
Okay, good evening, everyone. I put out the cross loop antenna one night after the local stations had reduced their power level, and magically almost all the intermod products and weird stuff is gone, so they must have some transmitter issues. I tried listening for WWVB on 60 kilohertz, but was not able to hear it at all. I subsequently discovered bad relay contacts in my Hermes Alex board, and so I've got to try again and put the antenna out. The model of the antenna preamp shows it's flat from about 100 kilohertz to about 10 megahertz, but that's SPICE, and so that may not be a reality. But at any rate, hopefully I'll bypass the bad relays on Alex and give it a try again. So back to the group.
Well, fine business. And next on the list is Elizabeth. Go ahead, Elizabeth.
Hi, everyone. So I also attended the CDAR workshop last week, and I also found it was very interesting. I liked all the talks and presentations that they had. Couldn't attend a lot of them, but I watch recordings from it. So, and here in Houston, we were going to start going back to the lab at the university, but we're looking at another shutdown again. So we're gonna go back and start working on some hardware with the VLF and the antenna, but now that's postponed because I'm also quarantined for 2 weeks since I was exposed to someone that's COVID positive. So that's it.
Well, good luck with that.
Have you been so even with the not being on campus, do you feel like you've been able to work effectively with your other team members and get some things done?
Yes, we have. We meet every week on Teams. So we have constant meetings on Teams to discuss, you know, any updates. So it hasn't really worked out that well because we need to go to the lab. And since I was the one that was exposed to, well, my uncle, he's in the hospital with COVID, and I saw him a week ago. And then I exposed everyone else when I saw them at the lab the last time we saw each other. So now, you know, we are going to work, but now we have to stay home. So
Yeah.
yeah.
Well, I hope your uncle does better.
Yeah, I hope so too. Yeah, he's not doing well right now, but we're hoping that since he's going through the worst phase of the symptoms right now, we're hoping that by, you know, this week he starts feeling better.
Yeah.
Well, we have 2 more on the list. The next is Robinette, AI6VN. Go ahead, Rob.
Hello, the group. I continue to be finishing our Whisper Daemon work, and for Veronica, if you want to do queries, and we have implemented a full SQL queryable database of the WhisperNet. So you can actually do complete queries. You can generate plots using full-on SQL, and it's a very high performance. If you get beyond a day or 2, it takes a while. The database right now, we have enough RAM for about, well, it's a couple days, and beyond that it starts to page. So it can take 30 seconds to do a query for a whole month. But you can do arbitrary. You can say whatever you want, you know, whatever, you know, limit your search in any way you want. And there's a Grafana interface that allows you to generate charts and graphs from your queries. So I think that if you're going to use a WhisperNet data to do research, I think we have the right solution, and you can find go to whispernet.org, and I'll post that up in the chat window. And there's a tutorial guide to how to do queries using SQL, and a guide that's been prepared to tell you how to generate charts and graphs from the WhisperNet data. So, and if you want to go back a month or more, contact me, and there's a different server that has a lot more data and is higher performance, the same mirror of it. But we're hoping that's useful to the larger community. But it's particularly, you know, one of our goals in putting together this database was to provide access to you know, a research quality version of the WhisperNet, because right now from WhisperNet all you can get is kind of the last day, 2 days, 10 days for, you know, very simple queries. But this is full-on SQL, so you can generate queries of any sort. So hopefully, if you have any questions, you can find my email, and I and Gwen Griffiths would be happy to help guide you through the process. Anyone who's interested in using that database. So I'll post that up in the chat window. The link.
We have 2 more on the list, so I'll move on. Next we have Scotty, WA2DFI, just a little late. Scotty, go ahead.
Hey there, Dave. Yeah, I'm running a little late after the ordeal on field day, getting back late and thinking I was going to get to take it easy today and rest. We had a water pipe break in our building, and it broke sometime over the weekend. So it was literally hundreds of gallons of water all over everything. So today was not nearly a rest day. No work got done. It was basically we called in the remedial outfit that brings in vacuums and fans and everything and cleans everything off. The only thing good we had about the whole thing was pretty much all the equipment has been moved out because today was supposed to be our closing day. So you can imagine if it was our closing day and we walked in and there was water, it was literally spraying out of the wall where the pipe broke. And so it was not much of a fun day, not much of a rest day. But our closing has been postponed for 10 days. So we got a little bit of time now to get the place fixed up. And another part of the good news is most of the damage to the walls and the rugs and things are in areas that the new owner was planning to rip out and demolish anyway. So we may have lucked out, but still going to cost us our insurance deductible. And I'm thinking, well, just to clean the water out and dry it out, you know, $1,000, couple $1,000. He says no, between $5,000 and $10,000 to do it. So basically, our insurance is going to pay, and then we're going to pay our deductible, which is $5,000. So that's it from here. Thanks, Dave.
Scotty, I do have something for you. Another organization needs you. I don't know if you looked at your email, but there's one email you have to vote on, and it needs to be done before the 15th of July because it has to do with taxes.
Yeah, and I've looked at the form already, so I just have to vote.
Yes. I promised Tom that I would give you a nudge.
Okay, thanks. I'm nudged. I will go vote.
Okay. Next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. Sorry that I joined late. I don't have anything prepared, but I wanted to talk about something that I worked on a little bit. I wanted to talk about adding VLF capability to the personal space weather station. What I did was I prepared a very basic outline of requirements. What I'm proposing is basically a board that will plug into either the high-speed port or the low-speed port, depending on the bandwidth. And we're looking at for three channels at 192 kilohertz sampling rate, around 9 megabits of bandwidth. So what I'm basically proposing is a sound card, a 3-channel or 4-channel sound card that will accept E field, H field east and west, and H field north south, VLF audio channels, and that data would be accessible over the network and can be processed digitally. Nathaniel had me kind of think about it and prepare something, and I was wondering what you guys would think, aside from characterizing the existing HF receiver, to see how well it would work with VLF. So I've been, I could provide my outline, but I don't really have anything prepared, and I apologize for that.
Can you send your requirements to the list?
Can you repeat that, please?
Could you send your list of requirements? You said you made up a list of specifications or requirements you need.
Yeah.
Can
yes.
you send that to the Tangerine list?
Yeah. Yeah.
This
Oh.
is Dave, and I wanted to make sure that you knew that we are contemplating a VLF. It's not an immediate task, but so you have a chance to have an influence on the specifications, or at least request the things that you're interested in.
Yeah, so Jonathan is actually a student here at the University of Scranton, but he's a more advanced sort of student. And he's also very much a VLF enthusiast, and he's been building his own VLF receivers for a number of years and is very active on the VLF natural radio listserv. And so he was over at my house for field day this weekend. And I know that we've been kicking around the idea of building a VLF module, not this year per se, but next year or the year after maybe. And so I actually asked Jonathan to put this list of requirements together. So I'm very grateful that he's done that, and he's willing to share it with the list here.
Yeah, I think that's something.
Nathaniel or Jonathan, didn't he speak at DCC last year?
That's right. Yes.
Yeah. Yeah. I did the presentation on VLF. And when I originally met Nathaniel, and he was talking about his personal place weather station, and he talked about adding VLF or lightning detection as an option, I got interested, and it seemed like an opportunity to create some high quality capture hardware. Currently, computer sound cards are used, and I figured this would be more of an easier, more modular approach. And there's a framework that we could work by. There is software called VLF RX Tools. It's open source, and it has utilities that will capture VLF audio from the sound card, and as well as GPS timestamp it. And then it also has utilities to process the signal and also do event detection. And what I was kind of proposing was the module would act as a front end. It would be the sound card portion and the GPS timestamping portion. And then you have that network stream of VLF audio, just like you would if you were to use a sound card. That's why that I kind of see this as an opportunity to make some high quality sampling hardware to sample at 192 kilohertz, and we could do some really interesting work. I will have to do some research on codecs and the front end circuit, but you know, something next year. You know, if you guys are up to it, I'm more than willing to be involved. So.
Well, this sounds like something we could implement using the lower speed interface. And so basically the high speed channels of the leaf interface, if you will, rather than put it on a module. But we do have two modules, so you could build another RF module that was a VLF module and place it on the board alongside the HF module that we have now. And if you're assuming that the HF module doesn't characterize well enough to do what you want to do.
Yeah, because I was thinking about that, where we could capture HF and also VLF with the other module, if you wanted to, if you only used one. So I figured that would be an option, or we could use the lower speed point.
Yeah, so I guess the question, that's why I want to see the spec to make sure as we wind up the data engine design here, I make sure there's enough high-speed channels on the leaf interface to accommodate a board like that. And that might make the board a little bit cheaper.
I was thinking about audio codecs, and I felt that would be probably the best way to achieve this, at least the simplest or the cheapest rather, and all you have to do is just clock in the samples.
Just be careful with audio codecs though, because even though they may go up to 192K samples or higher, they aren't necessarily characterized for audio input at that frequency. We found that with the Janus board, that the allegedly equivalent 192 kilosample per second ADCs or codecs were not, their performance drops off at the higher frequencies. The noise increases at the higher frequencies. So yeah, they'll encode there, but you're not going to get the performance that you want. And I don't know, maybe Tom has some information on that, because did you work on that, Tom, with when Bob McGuire and those guys evaluated the multiple codecs?
No, I didn't work on that, but essentially the codecs oversampled, and they pushed the noise up above Nyquist for audio listening. And so they were quiet down in the, down below 20 kilohertz, but pretty noisy up above 20 kilohertz.
Right, so you can sample at 192K, but then don't try to really sample anything more than 20 kilohertz, otherwise.
Well, it depends entirely on the codec, and you need to look into the data sheet. Because I used to work for Analog Devices in the audio group, and we wouldn't do that.
Anyway, we selected
That's
the
cheating.
AKM chip for use in the Janus because it tested well in the upper, it tested lower noise in the upper frequency ranges. So, but it's not cheap. So the question is, do you need 24-bit encoding or is 16-bit enough? What do you actually need, and what kind of speed do you need?
16-bit samples. I was shooting for around 9. Actually, you're talking about the master clock speed, right? Or the data rate?
Well, I'm talking about the rate at which you clock the ADC. So if you want 192K windows in baseband, then you better be clocking it twice that. And you're going to probably clock it more than that. So I'm guessing, because you can buy 16-bit 10 megahertz ADCs that aren't particularly expensive.
Well, that was another thing that I thought about. I was wondering if your FPGA could output a clock that could be used with this board, and I'm sure that there's a couple clocks being used with the HF boards, but that's what I was hoping, that we could use a clock generated on the FPGA rather than from a crystal or OXCO or something.
We can do that, but generally the clocks have a little bit more jitter and a little bit noisier than if you had a crystal oscillator or a BCXO. So if that's acceptable, then that's okay. But if you need extremely low phase noise and low jitter, then it's going to be hard to get that out of the FPGA. Because what we do is we take a higher frequency clock, we divide it down to some, whatever sample rate you wanted. Because it sounds like the sample rate's not very demanding, right? Because you're talking about 100 kilohertz maximum RF input.
Yeah, yeah.
The problem is if you reduce the sample rate to such a low frequency, then you better have really good filtering, because anything above the Nyquist frequency is going to fold back into your baseband that you're sampling, the data you're getting. So you have to be really careful there. Sounds easy, but it can really not be that easy.
Oh, okay. All right. Yeah. See, because I actually thought the opposite, that the FPGA clocks would have much less jitter, but maybe a crystal would be the better approach here. I don't know. It would require some prototyping.
Well, you do get less jitter when you divide down, but and of course our GPSDO, depending on what variety we use, may be able to generate the clocks that you need, because it depends on what the architecture is going to end up on the. There's going to be several different variants of the GPSDO, and they're going to use what's it called, Tom? It's the high speed. It's a digital high speed synthesizer that they use on that John was talking about using.
Yeah, I don't know the latest block diagram of where John is. So a couple of them had the pretty clean synthesizer. Forget the name of the company that makes it. Silicon Labs.
Silicon Labs, yeah.
Yeah, he had picked one that he had characterized quite well. And whether he's still planning to use that or have that available, I'm not sure. I think he had a different approach for sending the clock for the HF receiver.
Yeah, you don't generally want to clock a converter directly off of an FPGA because there's a lot of ground bounce.
Yep.
And you need to reclock it somewhere.
Yeah, we found a lot of ground bounce problems on Hermes, so not surprising at all.
Yeah.
Wow. Okay. All right. Yeah. That makes me think about this a little further. Okay. Well then. All right. Well then maybe a crystal is the best approach. Where I was going to start, I was going to look at some data sheets and application circuits of audio codecs. I was thinking of Wolfson Micro, maybe something from AD, and AKM too. So I was going to look at what they had to offer and look at their evaluation vehicles and see what might work the best. That's where I was going to start.
Yeah, and so the best solution, if you want to keep control of the ADC and all that, is to clock the ADC locally on your board and provide source synchronous data and clock to the FPGA. And then whatever, and as long as it's within the range of the FPGA's clocking ability, which it certainly will be, then it becomes pretty much, then you're in control of both the horizontal and vertical, so to speak, because you generate your own clock.
Yeah, I would say look at AKM, look at TI Burr Brown, and Wolfson also make good converters.
Mm-hmm. And I would like to see the specs if you want to post them on the target specs that you're looking for. That's always the best place to start for us.
Yep, we can help with that.
Okay, I will get them posted.
Thanks.
Mm-hmm.
Well, we're at the end of the list, and we're open for general discussion for the next.
Did you get Dan in there?
Huh?
Did you get Dan in there?
Dan was early before you came.
I thought he just showed up. Okay, never mind.
How about Michael? Did Michael get called on?
Michael got called on.
Okay.
We're just second guessing you, Dave.
I follow my list.
Scotty, did you get libraries for your FPGA?
Did I get libraries? How do you mean?
You were looking for libraries on the FPGA speed grade that would take the RAM and all the other, the -6, and you were looking for the libraries.
I have not got those yet, but they're part of what I requested from Intel, and I actually filed a ticket. I don't know what they call it now. They call it a ticket, which is a problem report. And there's still an outstanding question. At least I've been gone for field day for the past 4 days, so I haven't checked my email to see if I've got an answer yet. But they were supposed to get me an answer on whether I can do the on-chip termination without doing the dynamic on-chip termination. And then they're supposed to get me the -6 files for the i6. And so I can plug those in and see how close we get to meeting timing for the DDR3 memory with the i6 part.
Okay, so you're still waiting for those things.
I'm still waiting for that, but that's the last thing I need. So, and the CAD guy's already working on the models for the read-in. So we're going to have a jump start there when it comes time to release it.
Does anyone here have experience with roof-mounted and GPS antennas for use with the EDIS, like N200s?
I've got one Symmetricon antenna that was designed for outdoor roof mounting. It's basically a patch antenna inside a plastic container with a dome on it. The dome, I think, is mostly to discourage birds and nothing to do with RF. But it has a preamp and it's got a L1 bandpass SAW filter in it. So it's pretty narrow. It's about 20. I've got a, let me go grab it. I've got it over in the corner here.
Okay.
Nathan, the one that's over on the right-hand side there is what he's talking about, I think.
This one?
Yeah.
$50 on eBay?
Yeah. That's a very common one. Started out as an HP, went to Symmetricom, and it actually is made by Panasonic.
Now that's only L1.
Right.
If we're gonna go through the trouble of mounting one on the roof of the university, it might be good to get one that's multi-band, right?
Yeah, those are harder to find nowadays.
Really?
They're not common yet. L1s we have a lot of experience with.
Okay. If we went to like
But it might be that you get something like that now and get another one later.
True.
But that's the classic one that's very high gain if you want to run it very long distance. That's got like 31 dB gain or something on that order. There are others that are a 26 dB gain that still good for 100 plus feet of like RG8 or RG59, RG58.
So something with like 26 dB gain.
Yep.
Yeah.
And the cone is also to shed snow and things like that.
What were you going to say, Dev?
Yeah, I was trying to confirm that we're trying to build the SDR, which will receive GPS signals as well.
Yeah, so you have the EDIS 200 that you're working with has a GPS disciplined oscillator in it. So we need to make sure that you have an antenna that you can connect the GPS DO to. So Mike Neruda is holding one up.
Michael's holding one of those that I just pointed out.
And
Tom. They have a number of different companies have their names on them.
Tom's got one too.
So it will receive both HF signals and GPS signals.
Only GPS.
Just GPS.
Yeah. Yeah,
no,
there'll be
the N200.
Yes, that's right. The N200 will have two different antenna ports, actually 3 different antenna ports. 2 will be able to receive the HF, and then 1 will be able to receive the GPS.
Okay, that'll be very good.
What is the advantage of an antenna like that? A lot of the GPS receivers that you get now have a little button thing that sticks, it's got a magnet on it. You can stick it on anything metal. Explain to me how that antenna that you're looking at is superior to just the powered antennas that are very often provided with GPS receivers today.
Yeah, this particular antenna is designed for permanent outdoor mounting. And so it's weather sealed. It has the cone to discourage snow, discourage birds. And it's very similar to the hockey puck style antenna, I think perhaps that you're referring to. This one, I think has a SAW filter in it. And so if you have other RF interference sources that are nearby but outside the L1 band, it tends to filter those out. It's powered on the coax, just like the kind of antenna you're talking about.
Okay.
Yeah, the hockey pucks have a filter in them as well, but this has a much tighter filter to reject interference from frequencies to either side. They're also designed as timing antennas to reject signals coming in from the side a little better than a hockey puck would. Internally, it actually looks very much the same, but it's been designed in such a way to minimize side lobes and such.
Yeah, Dev is going to be installing this in a room that has no windows. So we have conduit to the roof, but there's no windows. So the little antenna that comes with it won't work.
You'll get no signal in there.
Yeah.
Can I share my screen? I believe I have an idea.
Go ahead.
All right. Let's see. Here it is. So this is the Trimble version of what Tom was showing. I actually spoke to one of the devs of GPSD, and he frequently refers to Trimble as basically you're paying for the name. This model, I believe, is around $150 to $200. But these antennas are specifically designed for timing, which I think would be good in this application.
Mm-hmm.
Yeah, so is that other one. It just doesn't have L2 in it.
Yeah.
The other thing, if you're looking around for antennas, you may want to find one that will do L5.
L1, L2, L5?
Right. Because L5 is the new civilian frequency that they're going to be using for improved characteristics and can be used for total electron content measurements.
I saw that the Chinese have their entire constellation up. Are we able to use theirs if we wanted to, in addition?
Are they using the same frequency band?
I don't know. I doubt it.
I think they all do share the band.
Oh.
The U-blocks do pick up all of the GNSS.
Yeah. L1 is used by ours, Galileo, and the Russian GLONASS.
Yeah. I personally haven't seen any timing antennas that support the L5 band, only L1 and L2. But I know Trimble has a bunch. This one is the what came to mind, and there's also the ones that U-Blocks recommends as well for their receivers.
Yeah, I think if we can get one that at least has L1 and L2, it's probably a nice thing. But
he's right. Trimble is a bit on the expensive side.
It doesn't need to be.
We all use Trimble here and there, but I know that antenna, and it is a bit pricey.
Yeah, looking at something like. True time.
So I saw your background. I thought maybe that was the antenna you wanted to use.
Yeah, this is. That would be very nice. That should have a little more gain than these, I think. We'll have to keep looking around. Anyway.
I'll ask the dev of GPSD what he thinks, and I'll get back to you.
You know who you might ask is John Ackerman.
Yeah.
Yeah.
Because he's working with dual band GPS receivers for Tangerine SDR.
Dev, do you know John Ackerman? Yeah, we'll get in touch with John Ackerman then. Do you guys mind if I show Tom Yarish some of the things we're doing with the Whisper data?
Well, we are at the end of our normal time, so
Oh, I'm
What
here
you
and
call-
interested if you want to carry
Yep.
on.
This would
Okay.
be called shop talk.
Okay.
Sure, I can show it. Oh, and one thing before people go, Urin is supposed to give the talk this Thursday at 3 p.m. So I will confirm that, and I will also send that invitation out to the list.
Very good.
So that should be a very good talk. So Tom, I've shown a number of these slides before. This is one of the things I'm currently interested in working on right now. I'm doing a little bit more work with it, but what you see here, these are all, it's a combination of both Whisper and reverse speaking network spots. And
Yep.
this is from November of 2017, I think. And what you have the 14 megahertz band and you have the 7 megahertz band, and this is showing a complete day so this is 24 hours on the x-axis here. And what you see on the y-axis here, this is the distance between the transmitter and the receiver, ranging from 500 kilometers up to 2,500 kilometers. And this here is all of the data over the United States, with midpoints over the United States. And what I'm looking at is you can see how the range changes in time. So I guess the skip distance edge here at the bottom, you can see it most clearly. Yeah, you can see how it's around 1,000 kilometers, and then about a half hour later, it goes up to maybe 1,200 kilometers, and back to 1,000 up to 1,200. So you see this wave structure move through the Whisper and RBN data. And the reason you're seeing this is because of traveling ionospheric disturbances moving over the United States. And this is connected, this can be connected to a number of things, but one of the things we think that's affecting this is actually changes in the neutral atmosphere, say like the mesosphere and the stratosphere can cause some of these effects. And so I'm working on some research, trying to understand that better and understand why, how that neutral atmosphere is coupling up to the ionosphere. I'm looking at this in the Whisper and RBN data.
Now, are these conditions useful for predicting propagation?
Eventually, because so I was talking with Jose Nunez, CT1BOH, who I believe he's a current world record holder for CQ Worldwide CW. And he was telling me the other day, he's like, look, there are days where I run VOA cap, or I look at the Whisper data and the FT8 data, and he's like, one day, propagation looks great on this particular path, and on another day it doesn't. But I can't explain it in terms of, looking at KP or, solar wind conditions or, geospace. And he said, why is that? And I said, well, one possibility is, we're not taking into account what the neutral atmosphere is doing. And so it's a very hot research topic right now. That's why we had Larissa Goncharenko talk at Case Western last year about this. But yeah, so if we can start to understand how these neutral atmospheric processes affect the ionosphere and couple, then that, potentially helps us, one more step towards prediction.
Okay, so you have this huge database of Whisper data.
Yeah.
And FT8 and whatever else, RBN.
Mm-hmm.
How much value is in it, historically? Do you go back more than a year or two in your analysis?
Oh, absolutely. Right now, Veronica, she's not working on this traveling ionospheric disturbance thing per se, but she's starting to look at the effects of geomagnetic storms. And I've started her looking at the years 2016 and 2017, mostly because that's the data I had laying around and easy to give to her. But yeah, we absolutely look at this in a historical context, and the fact that, Bill Engelke has a database that goes back to 2008. That's a whole solar cycle now. So
now, Which bands do you look at primarily? Is it just 40 and 20 meters, or are you looking at a broader spectrum?
It depends on the case, and it depends how much data is available on the different bands. So I've published one paper using these types of plots, and so you can get this paper. I'll put it in the chat here.
Good.
Chat. Where did my chat window go?
Okay.
There it is. Yeah, okay, there's the link to the paper. But when I did this paper, you know, I looked at multiple bands. So here was a good case where I had these 4 bands had good data or reasonable data. 7 and 14 are particularly valuable just because there are so many people there. You can see there are lots of observations here. And what we're looking at here is we're looking at a solar flare. So these are X-ray measurements from the GOES spacecraft. And you can see there's one X-class solar flare here and another X-class solar flare here. And you can just see how it obliterates the communications on the HF bands from 7 up through 28 megahertz. And then same thing over here when this one comes up. And yeah, I didn't include the lower bands here mostly because the data just wasn't good. This is in Europe. So this is just looking at the midpoints over Europe. And then this is over the United States. And so you can see those same 21, 28 megahertz, very poor data coverage. But this is early in the morning. So this is the dawn flank. You can see this dotted line here. That's the solar zenith angle. So when that's all the way up high, that's local noon, right over here. So you don't expect 15 and 10 meters to be open pre-dawn. And sure enough, they weren't. And here's 20 meters and 40 meters. And so 40 is, of course, kicking along very nicely. 20 meters picks up, you know, as the sun rises. And you can just barely see the effects of this solar flare here. And you don't see it as much in the United States because it is on the dawn flank. It's not, you know, getting the full effect of that X-ray energy causing the absorption. Whereas
obviously, some areas of the world don't have this level of data to offer, like Africa and other places. But what do you need going forward? What would enhance your studies?
What do you mean? What do I need?
Well, what do you're compiling this data set. What else would be meaningful? I mean, as you evolve your theory of these effects, is there other kind of propagation data that would be meaningful?
Yes, there's all sorts of data that's helpful. And not necessarily, some of it doesn't necessarily come from the hams. Okay, well this is actually where part of where the personal space weather station comes in. Okay. So I think I gave a talk at Contest University where I covered a lot of this sort of stuff too. Did I include that? So the Case Western group, they're working on a low-cost version of the personal space weather station. But what they're looking at is they're monitoring the Doppler shifts, or the change in frequencies observed by listening to WWV and WWVH in those standard stations. And so that tells you something about how the ionosphere is going up and going down. So that's potentially some useful information. What Dev is doing is he's starting to look at ionosons, which are sweeping the entire HF band. And so that's another set of information. There are systems. This is a great example. We were just talking about GPS before and GPS antennas, and I said I wanted a dual frequency GPS antenna. Why do I care about a dual frequency GPS antenna? Well, if you're listening to GPS on 2 separate frequencies, you can actually measure the delay of one frequency versus the other. And that delay is caused by the total number of electrons in the ionosphere between the receiver on the ground and the satellite in space. And that's what we call total electron content. So with GPS receivers like that, you can now get measures of the total electrons between the satellites in space and the receivers on the ground, and you can make maps like this.
Wow.
So here what you're seeing is that GPS total electron content data. And do you see this red and yellow stripe here? And do you see this blue trough here?
Yep.
That's a region of decreased electron density. And then you see this other yellow and red peak here. So this is a wave structure that's moving southeastward across the United States. It's a very large, coherent wave structure, and we're able to measure that with GPS. And from that, I was able to estimate the horizontal wavelength of about 1,100 kilometers, its phase velocity of about 950 kilometers per hour, a period of 70 minutes, and in what direction it's propagating southeast. And this is the same structure, I believe, that's causing this sort of oscillation we're seeing in the ham radio data. So I'm able to take a number of these different data sets and instruments and put them together. And then I'm also learning about, where do you go in the neutral atmosphere too to understand these effects. There's a lot of different places to look.
How do you define neutral atmosphere?
So the neutral atmosphere is any part of the atmosphere where that's not ionized.
Okay.
Okay. Now I should note that the neutral atmosphere is co-located with the ionosphere, parts of the neutral atmospheres. I have another good figure for that. I think if I go here, and
I can call the neutral atmosphere as thermosphere.
Well, it's not just the thermosphere. That's part of it. This one. This is a great. This is a really nice figure. So this is the structure of the atmosphere, and it shows you we have the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And what defines these different layers is actually the temperature structure. So you see in the troposphere, as you go up in altitude, the temperature profile is actually decreasing. And then when you get to the boundary between the troposphere and the stratosphere, you see through the stratosphere, the temperature is increasing again. Then you have an inflection point, which defines the boundary of the mesosphere. So now it's decreasing. And then you get to the thermosphere, so thermoheat, now it's increasing again. Now, all of these, so these are the different boundaries. Most of the weather, like thunderstorms, you can see here's Mount Everest, it all occurs in this first, 10, 20 kilometers of altitude. That's where all the weather is, and 80% of the mass is in this troposphere. 19% of the mass is in the stratosphere. And the stratosphere is very interesting these days because you get these things called sudden stratospheric warmings, where suddenly you'll see the stratosphere temperature rise, and that can actually trigger a number of events that we see in the ionosphere as well. And it also can lead to a breakup of the polar vortex. So that's very interesting. And then
Nathaniel, you might point out where along this the layers of the ionosphere show up.
Yeah, so it's just going to mention it. So this figure unfortunately does not show the ionosphere, but the ionosphere starts about 50 kilometers altitude. That's kind of like the bottom of the D region, and then it continues up. So then here where you see the aurora borealis, which should really be more around 110 kilometers altitude, that's going to be your E region ionosphere, and then your F region is going to be around 300 kilometers altitude. So the difference between the neutral atmosphere and the ionosphere when you get to the thermosphere is the ionosphere consists of all of the particles that have been ionized. So if you have a particle, a molecule or an atom that has had its electron knocked off of it, now you have a free-floating electron that has a negative charge, and then you also have a positively charged ion. That's the ionosphere. The thermosphere are all of the particles that have equal numbers of electrons and protons in the same particle. And those are the neutral particles.
Okay.
Does that help a little?
Yeah, it's very helpful.
Yeah.
Nathaniel, is that paper is excellent. Is it available for download?
This figure or the?
Yeah, well, you had a presentation, right? Is that part of a?
Yeah, this presentation. Yeah, it's on the HamSci website.
Okay.
If you have to go digging for it, I can probably put the link up. Yeah, it is up on the. If you go under publications, it was my AGU talk from this past year. So on the traveling ionospheric disturbances. And my student Diego, he's actually been extending this work. So he actually just gave a poster at Cedar, which I can put up. I can send you the link to as well, where he took this work a little bit farther. Find my chat window again.
So you presented that at AGU last year.
Yes, this is what I presented at AGU. Yeah. And then NSF CEDAR. And so here is, it's not canceled, it was virtualized. And then they had pre-recorded science highlights. Sanchez. Presentation website. Sanchez. So yeah, this one here. That's my student Diego. Oops, I'm sending this. I mean to send this out to everybody here. To everyone. Okay, so there's the link for Diego's thing. There's my presentation, and then there's the paper. So yeah, so we're doing more work on this.
Well, that makes me feel a little bit better about all this radiation I've been leaking into the atmosphere over the time. Somebody's doing something with it.
We're working on it. And yeah, and Veronica, she's just started this year. And that first paper I was showing you, she's starting to extend the work on that, on this first paper I'm showing you here. Because here we looked at, this figure. Here you can see this is KP up here in the green and the red. And this is from September 6th through 12th, 2017. And so you can see KP went up to, between almost up to 9. So it was a very large storm. And then you have the SIM-H index here, which went down to like minus 150 nanoteslas, which is pretty substantial. Another way of measuring storms. And here we're looking at the all 6 bands over the whole world. And this gives you a better idea of what the distribution, the global distribution of the WSPR data looks like. WSPR for about a week or so.
Yeah. Looks like 40 and 20 meters again with most useful.
Yeah. Well, I really want to show you. So yeah, so one takeaway from this is that we need to do more work in understanding, how these geomagnetic storms are actually affecting this, because I stared at this figure for a long time before I felt like I was able to write anything about it. And finally, the way I wrote something about it was this. I took all of the days. I looked at, I think, 2 years of data. So I took 2016, 2017, and I calculated I took out all the days that had very low KP. So basically geomagnetically quiet days, and I calculated the mean activity for those days. And this is basically the percent change from typical activity. And so you can see that blue is below average ham radioactivity and red is above average radioactivity. You do see some diurnal variations in here, or like day-night variations, I think. But you can see right during the geomagnetic storm, you get all of the reds disappear, and now you just see blues in these bands. And so that's when I felt like, okay, I can say something about what this storm is actually doing. But it's a lot messier looking at this during geomagnetic storms and during the solar flares. The solar flares, it's like very clear. You see a nice signature. These geomagnetic storms are much messier.
I have a question about the quality of this data in terms of, do amateurs observe holidays? Is there more amateur activity on the weekends?
Yeah, so absolutely. My friend Ethan Miller, he was one of the first people to be doing this kind of stuff. He has a really nice figure where he was like doing the Fourier transform of the whole year, and you could see like a 7-day cycle where the weekends are observed. But what I want to show you here is I've actually plotted an entire year's worth of data like that onto a single plot, and I can bring that up here, I think, to do the duo thing. And this is where Bill Engelke has been putting together all of this data in a format that's been easy for me to digest. And that's made a really big difference. Why is this not? Let me try this again. Hold on.
So you can offset or compensate for these weekly schedules when you're analyzing your data.
Yeah, and that's something we need. Yes, and that is something we need to do more of. We do have to be, careful with that. I don't know why that's okay. So if I go to Google File Stream, Drive, here, HamSci, Science and Engineering, ARC CSV, 2018. Okay, this is a figure. Yeah, so Phil just sent me all of the 2018 data. And yeah, so this is all of 2018, all in one figure. And so you can see these stripes where I think these are the weekends. And then this, is that CQ worldwide, or is that, but yeah, you see some of the big contests in here. They just stick out. And you can see, you can see what might be skip zones in terms of distance. We're going from 0 to 10,000 kilometers on this. Some things that might be skip zones, but it also can just be the geography of where the radio operators are. So, they're mostly clustered in the United States and in Europe. And so you get hot spots there, and then in between the US and Europe over the Atlantic. So that's where the hot spots are. What you're seeing here is the spot density of the midpoints of the radio spots on a log scale. So this is all of the WSPR and RBN spots broken up by band for an entire year, right for your viewing pleasure.
Wow.
Yeah.
Nathaniel, are you familiar with the DJ2LS heat map of spots?
The DJ2. Oh, I'm not sure which one.
Let's see. I'll give you a link to it. It's kind of it's a real-time derivative of the WhisperNet stuff. Here, I'll put it in.
Yeah, put in the chat. I have some of the data up on the on hamsci.org. If you go to hamsci.org/data, I have some some of these plots made up on a daily basis, so you can go and peruse them. All right. Oh, that's nice. So this is all like real time. Last 15 minutes. Yeah, people are doing some really nice stuff with visualization.
Wow.
Hey, Dev, you might mute your microphone.
That's pretty cool. DJ
It is.
TLS.
Wow.
Yeah.
Now, are the lower frequencies, LF and MF bands, of any use in this analysis?
Oh, absolutely.
So
Yeah.
I run beacons on 220, 2200 and 630.
Yeah, they're definitely of use. I haven't used those bands so much, but yeah, they're absolutely of use. One of the things to remember about the ionosphere, do I have that in this?
That's one of the reasons we're trying to get VLF into the Space Weather
Into the
Station.
fold. I think I made the point a little bit better in this CTU Contest University plot. You know, the ionosphere affects radio frequencies as a function of frequency. So here, you know, I'm looking at 15 and 10 megahertz, and 15 megahertz is not refracted as much as 10 megahertz is on the same for the same ionosphere. So here you see one hop essentially, and here you see 1, 2.5 hops. Same ionosphere, different frequency. So you want to look at how each of the different bands is affected by the ionosphere to get the most information.
Mm-hmm.
And yeah, certainly, like, I mean, well, you know, Jonathan will tell you, or David Denman HAC will tell you, yeah, there's a lot of very interesting physics going on down at VLF and the LF in that area.
All right, I'll keep the candles burning.
Wonderful.
Yes, one of my background projects, Nathaniel, is to put a 2,200 meter beacon up on Maui.
That would be wonderful.
So there's nothing out there. There is a very good 630 meter beacon.
Yeah.
Over on Molokai, but nothing at 2,200. So I have a good site there to do it but I haven't gotten to that project yet.
I know. All we need, people ask what we need. We need more time. I think that's
Yeah.
one of the biggest
Can you
things.
guess? Is there a time bank in the?
Yeah. If there's one thing we need more of, it's time.
Yeah.
I'm the final frontier.
Yeah. Yeah. Veronica, what have you learned so far about your escapades into looking at KP and stuff? You're just starting.
Yeah, well, I realized I accidentally mixed up the dates when I was making the graphs, so I don't have like 100% of the data for the for 2016 and 2017, but so far it's tough to exactly say what is going on, but it looks like in some of the bands, I think it was like, I'd have to look back, I think 2114 and 3.5, I want to say, there was like some interesting stuff happening when the KP index was higher, but I still have to really fix my my codes to have the right dates before I can really look at all the data.
Yeah, it takes a while to kind of wrap your head around all of this and get things straightened out, right?
Oh, could I ask one quick question? The ionospheric parameters in GPS data. I was looking at the GPS standard, and they're labeled alpha 0 to alpha 3. Are they used to calculate total electron content of the path?
I'm not sure about those. What I can tell you, back to my CTU, I think this Contest University presentation was like the most complete summary presentation I've given so far. So yeah, here's what you need for total electron content. So measure total electrons between the satellite and the receiver on the ground, 2 frequencies ionosphere. It's derived from the difference in phase delay between the two frequencies passing through the ionospheric plasma. Here's L1 and L2, what those frequencies are. And then here is the formula. So I pulled this from this paper here. So if we click that, and so you can, I think this paper is going to be available for free. Yeah, this is freely available, free access. So I'll put that in the chat too.
You know, I think I remember that formula actually, because I was kind of curious about it, and I do remember that formula.
Yeah, so there it is.
Perfect. Thank you.
You're welcome. Let's see if where's my chat? Here. There, the link for that formula is in the chat, or the link for that paper. I think, so if you go to the Contest University website, you can download this presentation, and at the end, how to do it, all the references are there. So
all right, thank you. I will download those. Thank you.
you're welcome. There's another good paper by Bill Rideout and Anthea Koster that kind of explains the whole process for GPS TEC derivations. If you want, Jonathan, I can send you that link or send it to you.
So I'm excited about the prospects of analyzing GPS data, which I wanted to during my graduate research, but which had not been successful. So I'm excited about that.
Yeah, I like the GPS data. It's a lot of fun.
So you should, most of the times you should make corrections for the elevation angles, right? Because if I remember it correctly, up to a certain elevation angle, they will be less reliable or something.
Yes, this is in this paper is the one that they do a good job of explaining how you can help take account for that. I put that link in the chat. So you need to be at a university or someplace to get access to this. But so yes, as you get lower, as the angle between the satellite and your station gets closer toward the horizon, the data quality for measuring total electron content gets worse. And they have an automated method for processing all of this. So if you go to MIT and you can go to their magical website and you go download the data from there, it's already been processed according to this algorithm, and you can basically get maps similar to what I showed in my earlier presentation, and you don't have to worry about that quite as much because a lot of it's already been taken care of for you.
Okay. Thank you.
I think Yuha did a more recent an update on that algorithm as well. Well, Bill, do you want to try getting on 40 meters?
Want to try 40?
I think so.
Doable? Switch the antenna there.
Got a frequency?
I don't know. We could try this. My radio is currently tuned to 7.175.
Sounds
Yeah, I'm
like
on
it from here.
W2NAF test.
7175 seems to be open.
I'm getting a lot of atmospheric noise.
I'm going to drop off Zoom.
We've got storms over here.
Okay. So for those of you who don't have ham radios at home, you can, like Veronica or maybe Elizabeth, you can try listening to us on the Kiwi SDR network. We're on 7175 kilohertz lower side band. I just put that in the chat. W2NAF test. So I might jump off of Zoom too, and I'll try to work some people on 7175, and we'll see what happens.
Nothing here.